Okay, so for this example, we have a given forward mechanism again. So this is the same scenario as the previous example, no? So we have the given angular velocities, no? Omega 3, omega 4, and then actually you have another given, for the angular velocity, which is the, where is it? Sorry, I need to change the pen, no? So you have this given, no? Angular velocities, you have omega 3, omega 4, and actually this is also omega 2, no? So this is your omega 2, and then you have the angles given, theta 3, theta 4, and then what else? No? So you have the lengths given, the lengths of the lengths given, and also theta 2. No? And then what we want to find is the magnitude of the absolute accelerations at point B and point C. No? So it is moving at a constant angular velocity. No? Remember that this is a constant angular velocity. Therefore, what does this means? Constant angular velocity means that the alpha, no, at this length is 0. No? So if there is an acceleration, then there will be an angular acceleration. No? I mean, if there is an acceleration with regards to the angular velocity, then there will be an angular acceleration. No? So in this case, we don't have a tangential acceleration basically, because we don't have alpha. So how do we now find the absolute accelerations at point B and point C? So as we can remember, you can figure this out, no? Well, for point B, no, for this point, we can find the angular acceleration there, since the angular acceleration, sorry, the acceleration, the total acceleration can be found at point B, that is equal to just the sum of its tangential, di ba? And the normal acceleration. So we're talking about vectors here, no? So it is not just adding these two terms, no? Although in this case, since the tangential acceleration is 0, because no, because the angular acceleration is 0, therefore the total acceleration is also equal to the normal acceleration only. So if you can find the magnitude of the normal acceleration, then we are good to go for point B, no? And B, no? So in here, how do we find the acceleration, no? Or the total acceleration? So we know that the normal acceleration is equal to r, no? Omega, no? Squared, no? That's it, no? So that is the magnitude of the acceleration. So AB is just equal to this, no? The normal acceleration. So we have here R2 and R2. So we can just solve this directly, So R2 is given. So we have 25 centimeters, no? And then you have omega squared. So omega squared here is 1 rad per second, no? So this will be 1 rad per second. So therefore, squared. So as we can see here, the unit will be 25 centimeter per second squared. No? That's it. For point B, we're over, no? Although the next one will be much more challenging, no? So to find this absolute acceleration at point C, basically we need to find omega alpha 4, no? So alpha 4 is a function of everything here, no? So A, B, C, D, E, F. So we want to solve for all, no? All these constants. This is not, they're not actually constants, but we can call them the parameters, no? We can solve for this using these parameters here. Ayan. No? Okay. So we can solve A, B, C, D, E, F, and then we can find alpha. No? So for, let's say, for solving for A, so we can just solve this using R4 and theta 4. So if you have R4, what is R4 here? We have 45 and then sine theta 4, so you have 98.95. So you have here the first parameter, no, for solving the angular acceleration at link 4, you have 44.45, no? So 44.45, ayan. Okay? So, you can use multiple decimal places or significant figures if you want it to be more accurate. So I'll just use 4 significant figures, no, for now. And then for R3, you can solve for R3. So R3 is equal to 60, no? So 60, and then you have here theta 3. So theta 3 is 22.34. So this will be 22.81. So 22.81. So I'll just solve this easier ones, no? So D and E. Actually, we can solve for E here. We can just change this into cosine. Ayan. So 55.50. So 55.50. And then for D, we can use this equation again. Just change this into cosine. So you have negative 7.00. Negative 7.0 01, no? Yeah. Okay. And then for letter D, you have sorry, not C, sorry pala, no. Negative 7.001. Ayan. So for letter C, you have R2 alpha 2 sine theta 2, no? Okay, so in here we know that alpha 2 is 0, so this will be just 0, and also this one. So we just have to start here. We have three. We only have three terms, no? So for this one. So R2 omega 2. So R2 is 25, omega 2 is 1. So 1 squared cosine, so theta 2 is 120. And then plus R3, so you have 60 omega 3, so you have 0.1538, sorry, times 0.1538 squared, and then you have cosine theta 3. And then minus R4, so 45 omega, so 0.566 squared. And then cosine theta 4, 98.95. So you have 8.945, no? So 8.945 or negative 8.945. Okay, and then for F here, so I think quicker way to do this, you can just make this negative, and just change everything to sign. So there's an easy way, to do this. We just have to change the signs, no? Change the signs and change the cos, no, into signs. So this will be sign, this will be positive, and this will be sign. So negative 7.950, no? Negative 7.950, no? So to find the angular acceleration at point 4, so we're only interested in point C, no? So this will be alpha 4. So you just have to solve this one. So CE over CE minus BF. So CE, so negative 8.945 times E. So E here is 55.50, no? Minus BF. So B 22.81 times negative 7.95. Okay? And then over AE, so 44.45 times 55.5, then minus BD. So BD 22.81, and then multiplied by D, so negative 7.001. Okay, so we have here an angular acceleration of negative, this is about negative 1, 2, no? Negative 0. Sorry, it should be negative 0.1200. Okay, so this is in radians per second, no? Squared. Okay, so we now have this angular acceleration. Actually, this is not the final answer. How do we now find the total acceleration, no? So to find the total acceleration, you can remember that for point C, no? So for point C here, you have the tangential acceleration, no, at point C, and also the normal acceleration at point C. So in here, if you can remember the equation, no, I have this in my notes already. So actually, hindi pala, no. I mean, you can do this as well, no, but I bet I'll just use another way, no, to solve this one. we can just use the x and y coordinates or x and y components, no? So we can just use the x component plus the y component na lang pala, no? So we know that the x component is equal to 7 point, you have here, sorry, not 7 point. So negative r4, alpha 4 sine theta 4 minus r4 omega 4 squared sine theta 4. And so in here, if you want to find the angular, the total acceleration, no, at point C, so this one right here, no, then you need to use the 4, no, the fourth link, of course. Okay, so you need to use the fourth link. So this will be everything that every variable here should be 4 based on our previous equation. So ito nga pala, no? Ayan, no? And then for the y component, no? So for the y component, it is also the same. It is just in the cosine function, and the first term will be just positive. So you have r4 alpha 4 cosine theta 4, no, minus r4 omega 4 squared sine, sorry, not sine but cosine theta 4, no? So if you find this x component, no, and y component, no, then you can solve this using the Pythagorean theorem to find the hypotenuse, di ba? So actually what we will find here is not the vector form, but actually the magnitude already of the x and y component. So we can solve this one, the acceleration at point C, actually the magnitude of at point C is equal to this the square root of this two x and y terms, no? Ayan. Okay. So let's do this, no? So let's do the calculation. So find the x and y component. So you have r4. So r4 here is 45. Sorry, negative 45. The alpha is negative 0.12. And then sine theta 4, sine 98.95. And then minus r4. So r4 is again 45 omega, so 0.566. And then sine theta 4. So you have 98.95. Okay, so you have 8, negative 8. Ah, sorry. Why is it different from my solution? Let's check this. So negative R4, sine 98.95. Did we forget the negative sign? Ah, cos pala, no? Ah, nag-swap pala tayo, no? Sorry, mali pala ako ng sulat. Ayan, naduling, no? So this should be cos, this should be sine. Ayan, my bad. Okay. Okay, anyways. You have sine here and cosine to the other side nga pala, no? Ayan, medyo naglabo-labo na tayo na naman. Okay, so this will be your value, 7.577. No? So 7.577 radians. Actually, this should be in centimeters per second squared now already, you know. Okay, if you do the analysis, no, sa units. And then for the y component, so let me just make things change this into positive and then change this into cosine. So this is still negative and then change this to sine. So if you change this one, you have negative 13.4. So negative 13.4, no? 40, no? Centimeter per second squared. So as you can see here, C here is accelerating in the x-axis this way by 7.55 and then accelerating as well in this direction, no? So the total component will be this acceleration right here. Okay. So Yeah. No, it will look like this. No, so in here you can just find the hypotenuse, no, or the magnitude of the acceleration by finding the hypotenuse, no, of these two components. No? So 7.7577 squared plus you have negative 13.4 squared. Yan. So you have 15.39, no? 15.39 na lang, no? Kasi for significant figures lang, no? 0.39 centimeter per second squared. Okay? So you have already this acceleration. So ganun lang naman yun. Okay? So thank you guys for listening and see you guys in class.